All right, what do we do if the curves cross between A and B? Well, if the curves cross between A and B, what you can do is look at where the curves cross. In this case, it's here at the point C, and we'll split it up here. So we'll do the integral to give us this area. This area is going to be G minus F from A to C. And then this over here, F's on top, so that's F minus G from C to B. If we add that together, it'll give us the full area. Now, this is another way you can do it by using an absolute value, but that's next to useless when it comes to doing these by hand, but it's useful when you do this on a computer. So let's do a couple of examples. All right. So this will find the area of the region between square root of x and 2 minus x from 0 to 4. Now, I'm going to come over here and graph that on Desmos. I've already got it written in. So y equals square root of x, and I've got it limited to just plot this between 0 and 4. And y equals 2 minus x, plotted over the same area, or the same interval. So let's, I'm going to make a rough sketch of that on my page. And notice where they cross right there at 1, 1. So let's come back over here and just sketch that down. So I'm trying to find this area and this area. All right. So from 0 to 1, we've got the line minus the square root. And then from 1 to 4, we have the square root minus the line. Excuse me, I'm going ahead and distributing that negative across there. So now we can do these two integrals separately. Notice though, the integrals, they're exactly the same except the signs are opposite. So this first one is going to be 2x minus a half x squared minus 2/3 of x to the 3 halves. And that's from 0 to 1. This one over here is 2/3 x to the 3 halves minus 2x plus 1 half x squared from 1 to 4. So now we've got to plug that in, plug these numbers in. So let's see, plugging in the 1, that's not too bad. You get 2 minus a half minus 2/3. Plugging in the 0 is easy, you get 0. Plugging in the 4, you get 2/3 of 4 to the 3 halves. That's 2/3 of 8. Let's see, minus 8 plus half of 4 squared, so that's plus 8. And then finally, plugging in the 1, you get 2/3 minus 2 plus a half. All right, let's see what this is. 2 minus a half, helps to turn this on. 2 minus a half minus 2/3. Okay, that gives me 5 over 6 minus 0 plus, let's see, these cancel. That's just 16 over 3. And then this last thing is minus 5 over 6 because this and this. Actually, no, it's plus 5 over 6 because both the signs inside of here are different. And then we've got a negative here. So the number inside of here is negative 5/6 and it's added. So what do we get here? We get 10 over 6 plus 16 over 3. Looks like 7. That's interesting. The answer to that is 7. Let's double check that on Desmos. Let's go back over here. Desmos. We can do this. I'm going to come back up here. I'm going to change this to f of x. I'm going to change this down here to g of x. And I'm going to do integral from 0 to 4 of absolute value of f of x minus g of x dx. And sure enough, it gives me 7 for the answer. So that's a good way to check this. All right, let's do one more example. Find the area between sine x and y equals root 2 over 2 from 0 to pi. All right, now this one we can graph pretty easily. And maybe we'll just set this one up. Let's see, from 0 to pi. Now we know what sine looks like. It looks like this, and this is pi right here. So what we're looking at, let me erase this and draw it nicer. What we're looking at here is this area. Let's see, here's sine, and root 2 over 2 is here. So if I draw this line across here, it looks like this. And so what we've got is 3 regions. We've got this region here. We've got this region inside of here. And we've got this little region over here. And we're supposed to add all this stuff together. All right, so where do these points cross? Where do the lines cross? Well, sine of pi over 4 is root 2 over 2. So we get that. And then by symmetry, let's see, that's 1/4 of the way. So this would be 3 pi over 4. Our graph is not very good, but because those should be exactly at the 1/4 and 3/4 points, but it's good enough. All right, so my area is going to be the integral of root 2 over 2 minus sine. That's going to get me this first bit. Now the second bit from pi over 3, I'm sorry, from pi over 4 to 3 pi over 4. That's going to be, that's got the sine on top. Why am I writing cosine? Minus root 2 over 2 dx. So it's got the sine on top and the line root 2 over 2x, or root 2 over 2 right there. And now I could go ahead and add on a thing for area 3. But notice by symmetry, area 1 and area 3 here are exactly the same size. So I can just do that. And that would give us the area. Although I'm missing my endpoints. This needs to go from 0 to pi over 4. All right. So we've got 2 integrals there, although I guess one of them's doing double duty because it's working for this area and that area. But if we were to add that up, that would give us this area. Let's use Desmos to do this too. Let's see. F of x equals sine x. G of x equals root 2 over 2. And let's limit both of these to just the part we want, from 0 less than or equal to x less than or equal to pi. I'm going to copy that and paste it in down here. So this is what we're looking for. And I think there are ways to get Desmos to actually do some shading for you, but I'm not going to do that. So let's look at this. Integral from 0 to pi of absolute value f of x minus g of x. dx, and it gives us this number 0.828, 4, etc. All right, so that pretty well finishes this section.